Hey Chem class, how are you? We're going to be dealing with molar masses, and it's super easy to be able to do, so don't fret about it. It should be really easy. All you need is a calculator, and you're going to need a periodic table in front of you in order to do this. And the biggest mistake people make is they just take it for granted. They're like, this is easy, and they don't practice as much as they should. The reason why you want to be an expert at this, and by an expert I'm talking like 95 or higher percentage on any molar mass I ask you for, is because it's going to be involved in some of the calculations we do later on in this section. If you get the molar mass wrong, all your calculations after that are going to be wrong, and then the whole thing's toast. Now, more likely you guys aren't getting an exam, but if there was one, typically there's like a 25, 30 mark calculation question, and people that get the molar mass wrong, they're done, okay? The other thing to keep in mind with molar masses is it's also tied into nomenclature. So if I give you something like cupric nitrate, and you can't give me the formula for cupric nitrate, then you're gonna get the molar mass wrong. Now your issue isn't molar mass, your issue is you don't know your nomenclature very well. But if you knew the formula for cupric nitrate was Cu bracket NO3 bracket 2, then you should be able to get your molar mass down pat, no problem. All right, let's go take a look and show you how to do this. Okay, so let's learn about molar masses. So you're going to be asked to find the molar mass of elements, which are super easy, and compounds as well. So the molar mass of SN, the lovely thing here is you don't even need to know what SN is. What you would do is you would find SN on the periodic table, and the atomic mass number is also the molar mass of tin. So that would be 118.71. And like I told you in the note, we want to keep this to one decimal place. And then don't forget your units, which would be grams per mole, all the time for molar mass. So gold, now in this case, you would have to know gold is Au. If we find that on the periodic table, hopefully you can see the molar mass there. Now, remember, we're rounding this to one decimal place, so we have to look at the second decimal place, which bumps the 9 up, which will end up bumping the 6 up. So that would end up being 197.0 grams per mole. Now, people always ask me, do you have to put 0.0? You don't have to. I highly recommend you do. It just gets you in the habit of always giving a molar mass to one decimal place, okay? If we do bromine, now the trick on this one is bromine is one of the bloody 7. It appears in nature as Br2, okay? So if we look for bromine, bromine is 79.9, and that's for one bromine atom. We have 2. There's 2 bromines, all right? So if we do that, that would be 2 times 79.9, and then you just punch that in your calculator, and I'm going to get 159.8, and again, grams per mole. Okay? Now, compounds. What you have to do here, you can really do this in 3 steps. So the first step is I want to know what elements make up the compound and how many of each. So you had to do this in your bonding assignment anyway. So this one here, I know I have a sodium and a chlorine to make this up. So then I look on my periodic table, and sodium is 23.0, and I'm also going to look up chlorine, which this one, the 5 is going to make the 4 into a 5, so that's 35.5. So I have 23.0 plus 35.5, and then that's going to equal 58.5 grams per mole. So those are the 3 steps I want to see for right now. This, the numbers, and then you can just plug in your answer, okay? This one here, this is ammonium phosphate. So I know I need 3 nitrogens. I'm going to need 12 hydrogens. I'm going to need 1 phosphorus. And I'm going to need 4 oxygens. So when you plug in all your molar masses, you can look on the periodic table. to verify that I have these all. When I plug those all in my calculator, I am going to end up with 149.0 grams per mole. Okay? Let's take a look at this one here. This is phosphorus 3 iodide, or phosphorus iodide, and I need a phosphorus atom, and I need 3 iodine. So again, what I'd like you to do is, if you have to, pause the video, but look on your periodic table and write down the molar masses for phosphorus and iodine. So phosphorus is 31.0 and iodine is 126.9. I'm going to plug that in my calculator and I will end up with 411.7 grams per mole. So that's a really high one. The last one we're going to do here, this is copper 2 chloride, or cupric chloride. And again, for this one here, I need copper, and I'm going to need 2 chlorines. Now be careful. Copper's molar mass is 63.546. When you round, it's not a domino effect. I'm only looking at the second decimal place. It's a 4, so I'm not going to round up. So that's going to be 63.5. And then chlorine is 35.5. When I plug that in my calculator, I get 134.5 grams per mole. Okay? 2 more examples I want to run through for you, and these are tough just because they rely on nomenclature. So like I said in my introduction, if you can't give me the formula for lead 2 carbonate, your molar mass is going to be wrong. So lead, symbol is Pb. It has a +2 valence. It also has a +4, but we want the +2. And carbonate is CO3. It has a -2 valence. When we crisscross, we would get PbCO3. Now, once you get that, then molar mass should be no problem at all. So to figure out the molar mass, I need a lead, carbon, and I need 3 oxygens to make up this compound. Lead has a molar mass of 207.2. Carbon is 12. And oxygen is 16.0. When I plug all that in my calculator, I am going to end up with 267.2 grams per mole. And that's how you would do that one. Okay? One more of these, and this is this one. This is practicing the Oshik system. So this is nickelous nitrate. Now nickel has 2 valences, +2 and +3. The OUS ending tells me I am going to use the smaller of the 2 valences. Nitrate is NO3. This is -1. So like I told you in the nomenclature section, if you memorize this, it makes it a lot easier. If not, then what you're also going to want to have handy is your valence sheet. So you can always flip to it and refer to the valences so you have them, okay? When I do my crisscross, I would get Ni, NO3, and this 2 that was up here has to fly down here. So that means I also want to put my radical in brackets, okay? Once you get this formula, then it should be easy. We're dealing with 1 nickel. We're dealing with 2 nitrogen. The number outside the bracket multiplies everything inside, and I'm going to end up with 6 oxygen. Nickel has a molar mass of 58.7. Nitrogen has a molar mass of 14. And oxygen has a molar mass of 16. So I am going to do that. And when I plug that all in my calculator, I get 182.7 grams per mole. So these are the 3 steps I would like you to do until you become an expert at it. If you're wondering when you're going to be an expert at it, I would say when we are done this section. If you feel confident, then skip those 3 steps and all you would have to do is give me the final answer. If you're not great at this, and by not great, I mean 95% or higher on all the molar masses, you're not getting molar masses wrong, then I would just do all 3 steps, okay? And that's basically it. Hopefully this makes sense for you guys. On your assignment that you guys are going to be doing, I just want the answer. So you might be wondering, well, why am I doing these other 3 steps? Now, I'm not going to be there to check it, but I would recommend you do this rough work and then just type this into your Word document for your final answer. Okay? Take care, guys.